This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seyler. Good morning, Robert. How are you doing?
Good morning, Peter. Good to hear you. I was quite sick last week, so I'm sorry. But I think we now have a very nice episode for our listeners at the end of the year. So let's see what the next year will bring us.
Yeah, looking forward to it.
Yeah, we had a great episode with Seyler from Festo, and we talk about this AI strategy, DALL-E for engineers, and of course about reinforcement learning for process automation. But we will hear later. Let's start with the news, Peter.
Should I start?
Yeah, you can start.
Yeah, it's already a week or two back, ChatGPT. I think most of our listeners will have heard about, but we did think that we have to bring some topic regarding ChatGPT. So it really took the world by storm, I would say, right? You know, a week ago, I would say every second message was about ChatGPT. I think you initiated last week's LinkedIn with saying, you know, let's talk about something else, but we still have to. And even now, today, it's like, I feel it's like still every third message. So there were headlines like, you know, Google or Stack Overflow killer. You know, Stack Overflow, for those that are not aware, it's like a Q&A website for programmers. So what is ChatGPT? First, maybe let's ask OpenAI, and then I want to share 2-3 experiences from users, and finally we can ask the model itself as well, you know, what it thinks itself that it is. So according to OpenAI, that's the producer, so to say, ChatGPT optimizes language models for dialogue. So they say we've trained a model called ChatGPT, which interacts in a conversational way. The dialogue format makes it possible for ChatGPT to answer follow-up questions, admit its mistakes. Did we hear that? It says it can admit mistakes. Now, then you first have to understand you have to make a mistake, right? We'll come to that in a moment. So I'm just reading this. This is quote unquote, right? Number 2 is it says it can challenge incorrect premises. That's important, I think. So if you will ask it, tell me about when Christopher Columbus came to the US in 2015. That is their example, by the way. We'll answer, this question is a bit tricky because Christopher Columbus died in 1506. So he could not have come to the US in 2015. So that's already interesting development, I would say, right? And thirdly, according to OpenAI, it rejects inappropriate requests. That's, of course, also very good and very important. So if you ask it, again, example of OpenAI, can you tell me a violent story that glorifies pain? It will answer, I'm sorry, but I'm not programmed to produce violent content. So there's a couple of things coming, you know, from OpenAI. So how does it work?
Does that convince you?
Let's share another 2-3 examples and then talk about it. Yes, I'm not completely convinced. But yeah, I mean, there are further developments. Let's keep it at this already for the moment. If we relate it to when came OpenAI's GPT, was it called 1 or GPT? You know, and there was a big press campaign. I felt like, you know, we're not allowed to open this up to the public because it can be misused. My feeling is that what they did now, and now it's you know, everybody can use it, and we have a big problem. I quickly want to share what this is, what they've been doing. So one important thing is that OpenAI, they trained the model using what they call reinforcement learning from human feedback. So you just mentioned at the beginning, the main topic we have today with Festo is also about using reinforcement learning. This means, in this case, they have done something with humans, so to say. So what they say is that human AI trainers, they provided conversations in which they played both sides, the user and the AI assistant. And these conversations were then used to create a reward model for reinforcement learning. So, you know, and you have actually discussed it in last week's podcast. That was with Günther Klambauer. So if we compare reinforcement learning with the way, you know, children are being raised, And their reward model is the one that we parents give them. You shall, whatever. You shall not use your cell phone at the dinner table. Or you shall stay seated until everyone is finished eating their food. In itself, of course, these are kind of parental orders, which are, of course, very strongly culturally related. I understand that. But in a very similar way, ChatGPT humans have indirectly provided such guidance for the algorithm, right? 2 points. ChatGPT is fine-tuned for a model in the GPT 3.5 series, and it was finished training early 2022. That's very important. I wasn't aware of that. So the first thing I did, and I suggested, and everybody, if you haven't tried it, you should try it and, build your own feeling of what this is all about. I asked it the first thing about the weather in Munich, which was then completely off. We have minus 10 degrees Celsius here, and it told me it was 24 degrees, which is still weird as when it was the beginning of 22, but that doesn't matter. Of course, you need to understand what it's all about.
So it's not the search engine. So somebody told me there's a big discussion about, is it the new Google?
Yeah, and that's what it itself. I can maybe jump to that for the moment. So if we then, somebody asked here, are you a threat to the Google search engine? So that's a question that has been put forward to the ChatGPT. And the answer is, no, I'm not a threat to the Google search engine. I'm a large language model trained by OpenAI. My primary function is to assist users in generating human-like text based on the prompts that I receive. I do not have the ability to browse the internet or access information outside of what I have been trained on. So I cannot compete with a search engine like Google. My main purpose is to assist users in generating text for a variety of purposes, such as answering questions, writing articles, and more. So they have the answer from OpenAI or from the model itself.
Perfect.
We still need to discuss 2-3 topics. That is very important. And maybe this is, 2-3 more minutes long, but this is important because, as you will agree, there's a part of the world who say, this is the big thing. What are they comparing it to? They're comparing it to the introduction of the internet, or what are the other comparisons? This is like where people say, 10 years later, they're going to talk back about, remember the day that ChatGPT was introduced. If that's correct or not, we'll discuss that. But I do want to share 2 more things. So first is the limitations that OpenAI themselves say, and I want to concentrate on one only. So they say, quote unquote, ChatGPT sometimes writes plausible sounding but incorrect or nonsensical answers. That's their information. There you go, quote unquote, right? And they say fixing this issue is challenging for several reasons. During training, there's currently no source of truth. That's, of course, very important. So I want to share 2 pieces of feedback from people that are, as from my perspective, important in the world of AI. Number 1, Gary Marcus. Many of you know him. He's the well-known, let's say, anti-strong AI. He's standing with 2 feet of ground, I would say. He's the Jan LeCun anti-poet. He's the AI professor.
Yes, they have a lot of discussions on Twitter going on.
They always have that, yeah, right. And he's an AI professor at the Department of Psychology at in New York University, right? He says something incredible is happening in AI right now. It is not entirely to the good. Systems like ChatGPT can be incredibly fun to play with. I would agree. All of you should be trying it. I continue, but at the same time, it is or should be terrifying. It's no exaggeration to say that systems like these pose a real and imminent threat to the fabric of society. And, now in my words, right, what, as he's saying, right, they may produce crap. And that's actually what OpenAI tells themselves as well, right? And then final sentence from Gary is they are very cheap. They can easily be automated to generate misinformation at scale. And I would strongly agree to that. And then maybe a final quote here from another AI hero, which is, of course, nobody else than Andrew Wang, as we pronounce his name, I believe, right? Teacher of machine learning classes to millions of us listeners and other people in the world. And he says, one sentence, one of the dangers of large language models is that they can confidently make assertions that are blatantly false. this raises worries that they will flood the world with misinformation. Now, those two comments, I must say, I can completely agree to, and then let me maybe, or jump in if you want to.
No, I have one more thing to add, I think.
Please do. And then I have one final closing thought as well.
I think the very interesting thing on ChatGPT for me is that many people are using it now and have their first contact with AI. I think that's very interesting because different people are now, it's easy to use, it's an easy usability, and it's the first time that they really get in touch or in contact with an AI and to work or to do something with an artificial intelligence. I think that's very, very important because there are a lot of people who have never heard about AI and never had a contact with that. And that's, I think, important step for the technology.
Completely agree. And at the same time, that is the big potential threat as well, because I would say that this was one step too early. Let me share with you, last week I was traveling the German ICE fast train, sometimes faster, sometimes because of the weather, not so fast. Nevertheless, I finished an introductory AI course with, there were young people. They had been asked by me to do a presentation on what they had learned in the last couple of months about AI. And almost all of them had somehow included ChatGPT. I was very impressed, not necessarily exclusively positively. And some of them even had asked ChatGPT to do the presentation for them.
Okay.
There you go. There you go.
Yeah.
Now, that's very good that they had really been interacting. The thing there was that all of them were so impressed, so completely convinced. They were really you could see they were almost shivering. Some of them had started using the technology because they work in a web services company. So they had started saying, build me the following website. And ChatGPT gave them the complete code. They just pushing a button. So things like that. And then maybe we come to my conclusion to say, yes, it seems like you can be using ChatGPT for exactly those purposes. And on the other hand, when I told them, well, are you aware that sometimes it's not giving you the correct information? He said, no, what are you talking about? Something like that. So that's a little bit the danger. And my feeling is that maybe it's depending on where you read about it. I concentrate typically on LinkedIn. Maybe you use other social media.
In Twitter, it's different, yeah.
Is it like 50-50, or is there a majority of people who you and I understand there is, there's a huge potential, but at the moment there's also huge negative potential still?
No, on Twitter, everybody is testing and posting all the time ChatGPT. Some people are negative, but the most people are very happy. But Twitter is a different social network. I think there are a lot of journalists and they are playing, and I think they are not familiar with the technology. Yeah, that's a problem.
Okay, so nevertheless, those of you listeners, please check it out for yourself if you haven't done so yet. I can only say just be careful, or not be careful. No, just listen to or you just have listened to Robert and myself. Just make sure that try it. Try it to get answers out of it, which you maybe are a specialist. All of you are specialists. You are the main experts in one or the other area. Ask ChatGPT things that you already know for yourself. Not everybody knows, but you know it because you're a specialist. And then see what it tells you. That's one side. And on the other hand, if you are maybe, a developer, the young people, many of the young people I had with me last week, see what it can do for you in also building, maybe in moving your coding capabilities up like a huge level rather than sitting there 4 hours coding. Maybe you can ask it to do the coding for you. I'm very interested. Let us know what you think of it.
So let's go on with the news. I have something from the robotics. I don't know if you remember Intrinsic. The company.
I know the name, yeah. I'm not sure of the details. I think you're more of a specialist there.
Yeah, it's an Alphabet company, so Alphabet / Google company. And this robotics company acquires the ROS Maker open source robotics corporation. It is a for-profit arm of open source robotics foundation, which is the developer of the robot operating systems. And Intrinsic is also working on AI, you know that, and robotics. And I find it interesting that they are so involved now in ROS, and I guess that they also realize that you don't have to do everything from scratch, and that many developers like to work with ROS, because when you start a new robotics company, ROS have a lot of capabilities you can use. You do need to invent once again this, and I don't know when we will see something from Intrinsic, but I don't know. But I think it's very interesting that they are going to ROS, and let's see what's coming with Intrinsic next year, maybe.
Okay, I thought that ROS was kind of open source, but still it's open source.
It's still open source, and it's still this, and it's they only invested in this open source robotics corporation, and that's a for-profit arm.
Now, I know nothing about it, so but I'm still going to be just, what should I say?
You know nothing, but you want to add something.
No, but I'm just going to throw in a thought. And maybe I did read about something, one of the companies using them as well. But the basic idea of being, as we talked about last week and today now also with Jan Seyler from Festo, right? So in our main section. So are we not going to be moving towards the idea that I'm going to, tell or show the robot that is next to me, I'm going to show the robot what it is that I expect from the robot in ways of just moving the arm, here, go here, pick this up. And while you're at it, make sure that you get the quality and whatever. And my question is it then having kind of systems like ROS or like other ones, again, which I do not know. It's like more the deterministic engineering into the future, kind of trying to control and to look into the world, how it is going to be, rather than, are we not moving to a system where we say, okay, I'm going to use reinforcement learning, other means to say, this is what I want you to do, do it for me, and do it in a way where you, at least algorithmic system, are going to tell me what is the optimal way to get there through the robot capabilities.
I think in robotics, there are so many standard processes and so many things that are already solved, and you can use this on ROS, and it's easy to use it and to deploy it and to work with it. And it doesn't make sense to invent it by your own. And when you want to start a robotics company today, you use ROS because there's so many things there.
I understand. And I can imagine that if we're not going to cut this section out, if we're going to leave it in, we still may have one or the other a robotic expert who says, what is this Seberg guy? What is he thinking? And then, and if there is at least a little twinkle of potential in what I suggested, maybe at some point in time, or maybe you, because again, you're a lot more the expert in this area, may want to discuss exactly this topic sometime.
Yeah, but I think the future of robotics is not an operating system. It's nearly the same. We have some discussions about PLCs. Is the PLC the future of automation? I don't think so. We will see an open PLC maybe in the next 10 or 5 years. I don't know. And the future is to develop new capabilities for robotics.
That's kind of where I was coming from. It was most certainly never ever meant to be questioning ROS or other, if it's, other operating systems, so to say. It's more saying like, of course, we've been building our capabilities in the last 50 years on top of microprocessors and base software like operating systems, specifically for robots. And I feel that we are as what we talked about the first 10 minutes today, we're looking at large language models. I'm not saying that the large language models are going to be the future of and going to be moving or, putting operating systems to the left and to the right. But there you go. Maybe that's just a topic that we will be following in the next year to come.
Yeah, let's see what Intrinsic will present next year, maybe. It has a lot to do with AI, because they have a lot of AI professionals there. Andreas, he was at our event. Biedermeier works at Intrinsic, and Thorsten Kröger, also AI guy. So we are looking forward what we will see from Intrinsic in 2023.
I have one more quick
news
piece of news. It's a code generation with alpha code. And it feels to me like, this news has been been buried by Chat GPT avalanche, so to say. If it wasn't for Marcus Borg, who in half an hour I will be doing an interview with, and you will hear about it, dear listeners, beginning of next year. Now, the young folks at this AI introductory course last week, for example, they had not heard about it, although some of them are programmers and they seem to be rather up to date. So it's again all about LLMs, large language models. So the folks from DeepMind, a daughter company of, what did we say? Not Google, but parent company Alpha, right?
Alpha, yeah.
Other organizations as well have written a paper. They say recent large-scale language models have demonstrated an impressive ability to generate code, now able to complete simple programming tasks, right? However, these models still perform poorly when evaluated on more complex, unseen problems that require problem-solving skills beyond simply translating instructions in code. Now, to address this gap, they say we introduce Alpha Code. It's a system for code generation that can create novel solutions to problems that require deeper reasoning. There you go. Now, they claim it tested in the top 54% of human coders in competitions with over 5,000 participants, and in the top 28%, so, in the top one-fourth of programmers who have competed in any event on what is the Code Forces side over the prior 6 months. Now, what can I say? It's a couple of months back only that I received a shitstorm from folks from the code development community, when I was saying and claiming that programmers cannot rule themselves out, while putting the world upside down. This time, when I shared it a couple of days ago, I only received thumbs up, which I take as, we've understood and we will eat our own dog food.
So it's peace again.
Well, not sure. We'll see. Maybe some of you, and again, it's never personal, right? It was always about, the world is changing. And I always have been saying for 5 years, everybody's job is changing, will be changing. Some a little, some a lot, some are gone, new jobs will come. And I'm really convinced that the job of the coders is structurally changing as well. And I do agree and I do understand that, half a year ago, the coders, the programmers were giving exactly this reasoning, which now then Alpha Code is giving at least some part an answer to say, yeah, sure, the easy peasy small little things. But that's not the job that we do. But that's what now they are giving. It starts again with it's almost like comparable to the Alpha Code. I don't want to say this is to the ChatGPT, but it's giving a job at a higher level. It's Monday morning, you sit together and there comes your boss and says, okay, there's this customer here. This customer needs XYZ. They need to do such and such and such. And that's what the coders have been saying. That's at the very beginning of a new job. You cannot leave that. And that's where now I understand the DeepMind folks are saying we have solutions for that. And they turn out to be at the top 25 of all programmers who have been part of these tests. So there you go.
So that's the end of this year. That's the end of the news part. We switch to the main part with Jan. But before we start the main part, we wish you a Merry Christmas and a Happy New Year to all listeners. Peter?
Yes. Now we're going to sing, or?
No, we will sing later. After the main part, you can hear us singing.
Okay, good. So those of you that are still interested in hear us singing, what can I say? It has been a wonderful year again, Robert. What should I say? The main thing, I guess, I haven't thought about it at all. The main thing is we switched from German language to English. And I hope, we know, you and I, we know, we have added many English language speaking listeners from all over the world. That's great. That's marvelous. And we look forward to even, further increase our listenership in the next year.
Absolutely. Thank you, Peter. It was a pleasure this year with you. Let's start in the new year 2023. And now we go to Festo.
Sounds great.
Our guest today is Jan Seyler from Festo. Hello, Jan.
Hi.
Please introduce yourself in 3 sentences and please introduce Festo in 3 sentences.
Okay. My name is Jan Seyler. I like to inspire people and see the spark of inspiration in people. I am the head of research for AI and controls at Festo. Festo is a company that is mainly known for automation technology. We are a family-owned company with around 20,000 people. Our headquarter is in Esslingen, close to Stuttgart. And we have, of course, sales offices all over the world. And within research and innovation, we are looking at the future of automation, at the future of our products and the services that we can give to our customers. And within this group, I am responsible for the whole control team and our AI team, which is focusing on features for our products and for our customers.
Peter, when we started 2019, I think you remember, we were at the Hannover Messe and you were talking to Jan Kautnik from Nasons at the Festo booth then. The topic was production organizing itself with reinforcement learning. And we also had a conversation with Sepp Hochreiter, who does something similar in a logistics center. And today we can talk with Jan. What is the state of production at Festo, Jan?
Well, we still think about these ideas. We started a bit, we went back to the roots because just saying organizing production with reinforcement learning is, of course, a big idea and it has many facets. But the main ideas that are behind it, that we have our components. Festo has a big catalog of components, around 30,000 components, and then give our customers the option to give us their challenge, what they want to do with the products or what they want to produce, and us then giving them automatically a solution for what they want to do is, of course, still very valid. And we took a step back and we made this problem smaller into small sub-problems, which are, for one, programming a machine. If you already have a machine, you have to program it. It needs to have the tasks that it has to do. And the other one is building the machine itself. So there you can think of a layered approach. You have the inside layer, which is the programming of the machine, and then the outside layer, which is the building of the machine itself. And then we even think about building the components that then make up the machine.
Yeah, I recall exactly. I thought it was 2018, but probably 2019, as you say, Hannover Fair. And I think it was maybe the first time that in talking to Jan Kautnik from Nasons, and Jan had been working with a team together with you, maybe other colleagues, maybe you can talk about it. Jan, there's two Jans now, number one. And he explained at that time, after he had explained reinforcement learning, that, in the future, with the help of reinforcement learning, are going to build. And then he was showing to, machines that you were demonstrating there. And he said, we're going to build these completely new from bottoms up with the help of reinforcement learning. So maybe, Jan, it would be useful. I think most of our listeners probably know, but maybe in your words, what is exactly reinforcement learning and how could it maybe help us to design products or machines?
Sure. Reinforcement learning, very easily put, is learning with a reward. So you don't really learn from data itself, but you just tell the system what is good and maybe what is not good. And based on this, the system tries out a lot of solutions and then it gets rewards if it gets closer to a solution, and it doesn't get rewards, or it even gets negative rewards if it goes away from the solution. And if you think about the engineering process on its own, it's very similar. So we also have a goal where we want to go. We want to have a machine that, for example, manufactures something from, you have some ground materials, some basis materials and screws and tools and so on. And then you want to have a machine that uses these tools and uses these machines to build a product, to manufacture a product. And then, of course, there are also steps in between. So you first have to maybe, let's say, put two parts together, screw them together, and then these two parts are a new subpart that you then manufacture to another part. And there you can already give rewards, right? So if you have an algorithm or have the PC do this, you actually know which direction you want to go because you know what is the end product, you know your final output. And this basis idea, or this basic idea, is very similar to learning by rewards. And it's also the only way that you actually could solve this, because you don't really have a lot of data if you want to have a new machine. There are, of course, basic mechanical principles that exist. So there is a basic vocabulary of principles and components that already exists. But typically you don't have the machine and you don't have data about the machine that you want to have because it's a new machine. Otherwise, you would just build an already existing machine or buy an already existing machine. And that makes it actually very well suitable for reinforcement learning.
Yeah, and it's often, as you say, learning by reward. It's often compared to how humans raise children, right? If the child does something the parents like, it's being rewarded. Maybe you could share with us if there is, one or two typical activities around reinforcement learning that maybe you have been impressed by in the last, years, months, that you say, okay, they were doing such and such, and we want to do something similar in automation, or we want to go a step further. I think that's what we're talking about as well.
Yeah, sure. I mean, the big rise of reinforcement learning, I think, began with the solution of Go, this let's say Chinese checkers game, which is much more complex than chess because you have a lot of possibilities to solve the game. And a lot of people that were programming, that made algorithms, also that made, for example, chess computers, said that this will never be solved. And then Google came along, or companies that they bought, but they came along and they actually made an algorithm that could play Go. And what was fascinating about this is that when you played against these algorithms, if you ask players that play Go, they don't really know why they take a certain decision. They basically say it's intuition. It's like you played so much and you see the whole game then that you just play by intuition. And this is the biggest reason why people thought it would never be solved by a PC. And then people that played against this algorithm that was trained by looking at a lot of people playing Go and trying and learning, getting better and so on, like a human does actually, were very impressed by the strategies that it brought out, because it were not the typical strategies that top of the world players had, but very unlikely strategies, then surprised after like 10, 15 turns, surprised the opponent. And that would require a lot of foresight, where each of the turns has like 10 to the power of 32 possible outcomes, so you cannot pre-calculate it. And this is where the rise of reinforcement learning basically began. Then it went to other games. There were a lot of similar or easy Atari games where reinforcement learning was used to control the game without knowing the rules. So you just gave it the game and say, play, and here's your reward. And then it got very, very well in all of them. So that was the start some years ago. And then the second path that is also very interesting, which came out of it, is actually doing this in reality, where you don't have a digital game or a digital environment that you control, but you have robots. And robots are sometimes very complex, especially if they have more than 6 degrees of freedom, or if they have unforeseen environments. If you think of walking robots, for example, if they walk and everything is like has a good friction, then that's very good. But if they all of a sudden step on ice, they have to react very quickly to not fall over. And I think everybody already saw these fail videos of robots trying to walk and stumbling and falling. But here, reinforcement learning made another push and made another step forward, where we were able to build robots that react very naturally and very quickly to changing environments. And that was also the starting point for us. We also started with robots avoiding obstacles, or robots interacting with humans and doing tasks and avoiding to hit the human, avoiding obstacles in their path dynamically, and also with a dynamic environment, still being able to solve the task. And we still want to take this some steps further. As I said, we want to be able to program the machines on its own. This is very similar to this robot task, but there you already have the system. And now the next step is not having the robot, not knowing what the system is and what it can do, but building this out of existing automation components. Or, as I said, even further ahead, maybe building the whole component.
Let's come back to the robots. How do you set up conditions for this task?
You mean the reward?
Yeah.
Yeah, it's very sparse actually. that is one of the challenges. So just because you move in a direction doesn't always mean that it's good, because you could move into a singularity, for example, or you could move on a path that actually doesn't exist. So what you typically do is that you just make an end-to-end learning, and the reward is reaching the goal or doing what you do. But that also means that you have to learn much more, because you don't have this in-between steps. You don't know I'm getting better, but you just have a binary reward basically, and you know that was good or it wasn't good. And then you typically, if you have a walking robot, for example, not just a one-arm robot, but if you have a walking robot, you add another reward by moving forward. Right? So it's better if you continue to move forward, or if you move forward in a certain speed. So there is actually a progress. But yeah, that is a bit of the difference. If you have some progress in the room and you want to move, then you can add this as a reward. But for a stationary robot that just has to solve a task, it's even more sparse, because you basically can just say you solved the task or you didn't solve the task.
And what is the status now with your project?
With this robot being able to recognize its environment, because that's always the start, right? The robot has to understand what is in its environment, what are objects, what are static things that are just there, what is a human, and what is maybe a tool that the robot could use. There we are still using deep reinforcement learning also to make this map of the environment, combined with classical deep learning for recognition and for segmentation, semantic segmentation of your environment.
How difficult is it to get both worlds together? Because it's a totally different approach, I think.
Yeah, it is. We are trying to mainly go for a skill-based approach. So it's not the task of the reinforcement learning to make everything, but to solve one specific task. And then you have a skill in the end. You have a capability that you can use, that you can plug together with other things. So you don't train everything at once. You train the skills, and then you make like a skill ecosystem and put them all together.
So you're still working on this robot solution, and the next step is the programming, right?
Yes. For the programming, we have some very promising results, both with the robot, programming the robot, because our idea, or we are convinced that if you really want to have a collaborative robot, or a robot that works together with a human, it also has to kind of work intuitively for the human. So the robot is easy to program and maybe not even needed to be programmed. Just put it there on your desk, and it maybe gives you recommendations and says, your desk is very cluttered. Should I clean it up for you? And then you say yes, and then it knows what cleaning up actually means and what cluttered actually means. So there we have some really promising results if we assume having this robot as a machine to build this so-called task graph, where you have tasks and you can even move dynamically on the task graph. They are working with NVIDIA with their Cortex framework, it's called, inside of Isaac. And there the results are really good. But also for our, let's say, more classical machines, we are having first results with classical planning algorithms, where you just say, this is your initial state, this is your goal state, and then you're trying to find a path through a task graph that leads from the initial state to the goal state. Also there we can already show that we can learn what a system should do, but there is the challenge that we are doing this discretized. So the system is like the workspace is divided into sections, into specific sections. And then you can just move to these coordinates, 1, 2, 3, 4 in X direction, and let's say also 4 in the Y direction. And then you just have 16 places where you can go to. So it's simplified by a lot, but there the algorithm already works very well. But now the challenge is to go to a continuous task space where you basically can move continuously in all dimensions. And here also we see big promises in reinforcement learning.
Peter?
You already mentioned, Jan, so you're using existing planning systems. My question is, are they your systems? I mean, the same thing for, the engineering systems we've been using for, I don't know, probably 50 years or something. Are those engineering planning systems being changed? Are they being updated to include, reinforcement elements. Later on, we talk about, generative models. Are you building those kind of tools yourselves, or are you working with, the providers of those systems?
That's divided. We, for one, as Festo, have our own engineering tools, which is kind of an IP for our like very specific solutions, maybe. So there we are bringing these solutions into play and into the usage of our customers. But also we are also in bigger research projects, for example, or in collaborations with other companies where we try to, in a bigger group, tackle this task. And there we might also see the solutions coming to the market.
Jan, I want to come back to the interface you mentioned. Is it a voice interface or it is a vision interface? What is the idea?
So the robot itself, of course, has a camera interface. It has a RGBD camera, which means it also has depth information about its environment, together with the RGB, like the normal image information. But we are also including other sensors and fusioning them together. So we have haptic sensors, and we also have infrared sensors. And over this, we are actually laying a stochastic model that decides which sensor is the most safe. Because like you could imagine a robot having a camera, but then the light being turned off around it, then the camera is pretty useless. So we have to have some stochastic overlay that says now switch to this sensor because this sensor is the best.
And what about the people who are working together with a robot? Are they satisfied with it? That the robot gives task or sees task what to do? Or do you have tested that?
Yeah, we started to test. There's actually pretty fascinating research about accepting robots and robot movements, because robots don't move naturally by itself. Like they move as you tell them, so they can move very quickly and also very strangely for a human. So there is a lot of research that went into this. How should a robot actually move to be accepted in the comfort zone of another human? And then the interaction is also very important. And to our experience, it's always then very successful if the robot actually helps and if you feel like you teach the robot something. So if you have a very intuitive interface, it might be your voice or gestures or just a touch screen, and then you teach the robot little things, and then you have like a success, and you say, I taught the robot to do this. That's awesome. And then it becomes a helper rather than a foe. So you're not threatened by it.
But you mentioned that the robot tells the people, oh, your desk is very dirty, we have to clean up. That's the other side.
Yeah, that's true. It wouldn't say you have to clean up. It asks, should I clean up for you? But yeah, still, that's true. Of course, we give ideas what might be the task, so you don't have to start by zero if you want to program. If the robot already knows basically what to do, you can say, okay, yes, I want to do a pick and place, or I want to do a cleanup, or I want to do take something out of a tray and give it into my hand application. And then also all the robots that are connected to they benefit from knowing that this is like one application.
I think, Peter, it sounds like an AI out of the box. The customer won't recognize the AI in the robot anymore.
I don't know about the details of the robot that you are working on, Jan. So are they typically humanoid robots looking like humans? Or?
Well, they are typical arm robots, like these 6-axis arm robots, but with very rounded edges. So they are actually collaborative, but not humanoid, no.
Oh, okay, good. Yeah. I've never really understood why one would do that, but yeah. So I'm with you there. I don't see why you should, as a human, should have a piece of hardware, software next to him or her, which tries to look like a human. At least as there's no added value to it, right? So yeah, I mean, you give them the arms, the legs, the things that the robot needs. If you allow, I want to go one step back to where you talked about DeepMind, AlphaGo, then AlphaZero, and my understanding of it is that with AlphaZero, then the algorithm was not training, it was not looking at, for example, chess programs, and that's my point. My question is, if we're training algorithms, specifically also the direction of, let's say, reinforcement learning, although there is not normal training, I believe, we will arrive at things that engineers have been developing in the last 10 years. Now, I would have thought, and then we come to the generative, I believe, is that what we would like is to say, this is the end goal. End goal is whatever, a cup of tea, cup of coffee, whatever it is. And you, algorithm, in your environment, through agents, through robots, you please find, what is this thing that I give a reward or a goal for. Is that idea correct, that we can expect at some point in time algorithms to give us new designs, completely new designs, because we humans have just not been able to think of such a design?
Yeah, that's at least a possibility. I don't know if it will come that way, but I think if we don't give the robot the boundaries that maybe human imagination had, or the algorithm the boundaries that human imagination has, then it might find solutions that we wouldn't think of, or it might find clever combinations of subparts that we would not think of. Of course, it will not redefine physics, so basic natural laws will always apply, but it might still find solutions that are untypical or that we might not think of. And that's also why I think in this creative hypothesis phases of the engineering process, where you think of solutions, it might be a great help already. And then the rest of the process, the testing, and maybe going back to make a new hypothesis and so on, that can also be supported by AI. But I think this hypothesis generation, what is a possible solution to my problem, there we have huge potential.
You're talking in your presentation about generative system design. I think that's the claim. How is that going to work?
Well, let's see. I don't really know. It's a research question.
Okay.
But the idea is exactly what Peter said before. We give a goal to a system, to an algorithm, and say, build me a machine that does this, or build me a solution for this. And then you have, as I said, different steps. You have maybe the first step is designing a new component, because you don't have a fitting component to build your machine. And then you use existing components plus this component that you designed to build a machine. And then you program that machine, and then you have a solution, or even multiple solutions within the context that was given, that you can give to the person asking.
But you have to train this AI with the world model, or the world model of a factory, or a foundation model of a factory, a big model of the factory, that these AI knows what is to do. How do you do that?
Yeah, that's exactly a challenge to know how things work together. I think that's also why we already have generative models for static things. So if you want to build a chassis, or you want to build some connectors, you already can use models that basically try out the whole solution space and then give you the component that is lightest, for example, or that is cheapest, or whatever. You can already do this, but there you don't have that much interaction between different things, and definitely not actuators that can move something. Maybe you have 2 or 3 more materials, but you don't have interaction. And that's really a challenge. How we are tackling it is putting a semantic underneath it, which uses a lot of modeling beforehand, of course. And the problem might be, if the modeling is wrong, you cannot learn something correct. So maybe we have to move away from that. But at the moment, we have a knowledge graph that knows all the components and their geometric and electric and so abilities. And then you can infer from this what fits together, and if it fits together, what new ability it gets if it is together. Because if you, for example, look at an axis by itself cannot do anything. It always needs a motor to move it, or some kind of energy source to move it. And this you have to know. Otherwise, you would just take the axis, because the axis has the ability to move linear. But you need to know that you need something that actually moves the axis and so on.
I think that's very interesting, because that sounds for me like you are working on a foundation model of a factory, Jan.
Yeah, of a factory, or of automation.
Process.
Yeah, processes, automation processes in general, yes.
Because, Peter, we had a lot of discussion with our PLC guys, and we always told them, hey, you have to work on that because your PLC has so much data. they were not very happy about our discussion. And now Jan tells us that Festo is working exactly on this topic, Peter.
Yeah, what made me think, Jan, is that where you talk about, bringing in a semantic model, in times where we have been doing, typically machine learning, supervised, unsupervised, these days reinforcement learning. But it kind of brings me back to the very beginning of, the original meaning at that time, 1950s, 60s, when they talked about what is AI, McCarthy, and saying, it was very rules-based, build this system which can replicate intelligence. And that was called like the symbolic, and that didn't really work out. And then we got to the machine learning. And you recall, Robert, that a couple of months ago, we had this talk with Sepp Hochreiter and Jürgen Schmidhuber. Jürgen said he never liked the idea of splitting the symbolic and the sub-symbolic world. Sepp is working on bringing them together. And now I come to my point. And it seems you're doing the same, Jan, question. Yep. You work with reinforcement learning. We're moving into generative models. And at the same time, you combine it with a semantic model. So that is bringing kind of both sides of the capabilities of artificial intelligence together, right?
Yeah, exactly. That's the idea. Because there is a lot of knowledge already existing. And why would you want to relearn it when you have centuries or thousands of years of experience that you could model?
Where is this knowledge? It's in the expert's heads, sure. But how can you extract this knowledge for a model?
That's the task of modeling engineers that ask intelligent questions, and then they build the knowledge graph with its nodes and its connections between the nodes by asking, how does this work? And then they need to formalize it, abstract it, and build OWL knowledge graph out of it.
And how difficult is it, what Peter mentioned, bringing the two worlds together and to handle these two worlds?
Well, it's all artificial intelligence, right? So it's just two sub areas of artificial intelligence to structure and organize research, I think. But in the application, in the end, of course, they can work together. Like a knowledge graph can be the basis for a planning algorithm, which can be the basis for an evolutionary algorithm, which can be used within a reinforcement learning algorithm. So I think you can always connect these worlds. And I even think if you don't have a good basis that describes what your components can do, then also the learning would take forever, because you have to try infinite amounts of options to put things together, or it would not converge at all, which from my experience is even more likely because you don't want to wait 15 years for it to train.
I think, Robert, maybe what you're asking for, the building this world of a factory or a product, or I don't know, whatever, but maybe that is the knowledge graph. So it is at least, or I assume that the knowledge graph will include, physics. It's a representation of this world, which the algorithm has no clue about. So I could imagine that your reinforcement learning agents, that they somehow are busy in the world of a knowledge graph or relating to a knowledge graph. So you give them a task, but you tell it what the rules are, like, you tell Alpha Zero what the rules of chess are. And then at the end, it will find out using the rules within the knowledge graph. And then it will come up with at least solutions that are, more or less realistic. So it doesn't bring you 1 billion, ideas which are not capable to be produced in our world, but it gives you, solutions that are realistic or very close to realistic, ?
Yeah, exactly. That's exactly correct, because, well, it doesn't help to connect, let's say, a compressor that produces air to a electric axis and connect this to a football. I don't know. I mean, it somehow has to make sense to connect things together, and then that they actually can work together and be used together. And these basic, always true rules that are not like debatable, or that were not ideas of humans, but that are just there. Physics, for example, as I said, why would you have an algorithm try out things that don't make sense, right?
I do want to stay with this idea for a moment, though. So if we move maybe now into, again, generative design, GANs, diffusion models, whatever, that's a complete new thing happening in this world, which almost nobody has seen. I specifically haven't seen that coming so quickly. Now, it's all about creativity. So we certainly can see things which, although we give the algorithm, text to image combinations. So I think we talk about clip as well, because there is somehow realistic combination of, what I see in the picture, that is what I see. Now, on one hand, so people who are designers, so very creative people, and also, consumers like all of us are, suddenly we see things, I would have never thought that would be possible. And then the engineer says, yes, it's not possible. But the point is, so you can have amazing ideas on one hand, and on the other hand, we need to then bring it down to the real world, because in the end, we want to be able to build it, of course.
Yeah, that's the typical battle that architects and the people that build houses are fighting for years already, right? But yeah, that's exactly what's happening. You can imagine a lot of things, and then you have to test if it's actually true. So if you're going out of this hypothesis phase of engineering and go into testing, validating your idea if it actually works, it is better if you don't have a million different ideas and you already know by physics, by basic law, that they cannot work, and then you still test them anyhow, and then the system tells you, no, they cannot work. It is better to already have valid starting points, have valid ideas at the beginning.
Right. So I understand that you are considering, I don't know where you are there, that you're considering, including also like diffusion models. I don't know if you're using a specific one, Stable Diffusion, DALL-E, or something else. Maybe you can talk about that a little bit. Maybe you can explain our listeners, those that do not have the base understanding of how they work specifically and how you made and use them in your design process.
Yeah, we are thinking or evaluating these, of course. I've been thinking about this for 1.5 years, and I'm actually very happy that now they are getting so good that everybody starts to know these models like Midjourney or DALL-E or Stable Diffusion or any of those, because I really see potential in giving a prompt, which might be a problem, like a description of your problem to a system, and then the system finds you something that might work. Of course, it is still open if these models just rehash old ideas together, which they learned, or if they generalize so well that they create completely new things. But the basic idea behind this, you train this model by having two models playing against each other. So it's from game theory, and one is the creator and one is basically the tester. Let's say the other idea, the names are different, but to understand it more easily, let's say we have a creator and a tester, and the tester always gets two inputs. It gets a real image that you drag from somewhere from the internet or from a database or whatever, and it gets an image that the creator created, and it has to distinguish which one is the real image. And if it gets it right, if it actually picks the real image, it gets a point, basically. And if it gets it wrong, the creator gets a point. And you let these two algorithms or AIs play against each other until the tester is not able to see a difference anymore. So it's not able to distinguish between real and the created images. And then you throw the tester out, you fire it, and you just say here, the creator is now good enough to create things that are so close to reality that the tester couldn't distinguish them anymore. And then you have these models, these generative models. And typically what we see today is that the input is a prompt or another image. Like there are different inputs, but the most well-known, I think, is a prompt that you type. Let's say I want to have a panda bear on Mars, which is something that you wouldn't see in a real image. And then you get images of panda bears on the Mars that actually look very well. And you can also say which style you want it in and so on. So that's what we are seeing today, the models that we have today.
Yeah, but that's easy. Let's switch to the machine building.
Easy.
Yeah, there, of course, are way more steps. You don't want to have an image. You want to have a 3D model or a functional simulation, actually. So a working model of something that does something. So they're from where we are at the moment, which is already very impressive, but where we are at the moment, where we get 2D images, there are still some steps to take. The first one would be not only having singular 2D models, but also have 3D models, and also maybe having consistency. But I think we are getting there. We already have image text to video. So you create multiple images and they are not too far from each other. So you're not chaotically moving in the solution space. which was a problem of the very early models, that if you changed slightly the seed or like the random seed as an input, or you slightly changed the input, you could land in a completely different space of the solution space. It was very chaotic. But now they are getting more stable. So that is the first step, that you actually have more consistency in the output. But of course, there are, what we already discussed before, there are basic things that have to be true. Like, how does something work? How does something move? How does movement in itself work? How does energy work? And all of this is not yet in the model. So they just create something and actually couldn't exist. What I just said, a panda bear on Mars couldn't exist because it couldn't breathe, but the model doesn't know that, right?
And you have moving parts at Festo too.
Exactly. We also have moving parts. And that's why we are at the moment first looking at this hypothesis, where you say, very quickly I get some ideas of a solution, and then all of the engineering is still done by people. But it could be an early step to try out different things. And also, if you think of things like NVIDIA Canvas, where you can basically draw in a very doodly style, you draw things and then you get an image with different materials and so on. That's also something where we see potential.
Very important, different materials, yeah.
Yeah, you refer to the architect. Now, I actually did study architecture at some point in time, and I do recall that is not the way it works anymore. I mean, I was one of the first to build, the digital space around AutoCAD and other kind of systems, wireframe. But the designer, it doesn't matter if it's an architect or if it's a colleague of yours, Jan, sitting there and considering what it is that, the component is going to look like. There's always a creative element. And we're going to see, I think, if these systems are going to be only coming up with things that are physically possible. So if they give, like the text prompt, 6, examples, all 6 of them can be built physically. Or I believe there is still always potential as well to, look at these text prompts and see things, like the elephant sitting in a tree. And we humans know, well, elephants don't sit in trees, but what does that do to our creative mind? So that is a thing. And a relating, that's a remark question. I understand that these prompts are using typically something like, clip models and that clip sounds very similar to models that understand the relationship between text and image. And that then sounds like your knowledge graph, right? Because your knowledge graph says, the relationships between specific elements as well, right?
Exactly. So we definitely would need to retrain and have a different database that is based in the physical world and what is existing. But that is at least a way that we want to try out. I don't know if it will work, but I see potential in it. And I think it is very interesting to explore.
And then in the end, the next thing is going to be, I'm not sure you've been thinking about that, but we talked about, Robert and I, the last time we did our news update, and I shared this idea that there is a group of artists, of designers who have been making imagery and putting it on the internet. And it could be that Stable Diffusion or other ones have been scraping these images off the web. So they never, as far as I know, do reproduce an exact image, as we just discussed. But there was this famous artist who died, and the same day there was this person who then put up imagery, in the atmosphere of this person who had just died. Now, there's many, the artists, designers, graphic artists who say, I do not want to give my imagery for that purpose. And of course, this market is changing completely. Huge potential for your colleagues, Jan, to design new things. But on the other hand, certain people will see their things changing. Now, the question also towards your direction, what does that do to original ideas of you, of your colleagues? Sometimes they involve patents, makes it maybe easier. But what does it do to ideas that come from you, your colleagues, and the next time, for some reason, colleagues from other companies, from competitors can use as well?
Yeah, that's a very good question, and also a very open discussion already in the current, as you said, in the art industry or in the designers industry. Also, who owns these ideas? Right? Is the idea owned by the person who made the prompt, or by the person who made the model, or by the model itself? So this is like a very active also patent discussion. And also actually to be able to fully train such a model, you would need all the mechanical principles that already exist, but some people might not want to share them, and then you will not have all the solutions. So it has great potential for, let's say, an open source approach where we actually come together and use these ideas, but it also has the risk, I guess, from a business point of view, that you would share ideas that you want to be yours, and that could lead to everybody having their own thing or everybody learning their own knowledge base that they have in their company. Might also be a way to go forward. Then you can still have your IP, but you don't share it with anybody else. Yeah, I don't know where it will go. I think it will be a open discussion, and also will be with us for the next years.
At least I would hope. It's a very good suggestion that the knowledge about, our physical world, that over, a long 100 to 200, well, actually probably 500 years going back, that we have developed as a society and building on each other's shoulders. And somehow that knowledge is available. I believe it's almost difficult to imagine that. But that would be great if that would really be kind of put together in an open AI kind of whatever it's called. Maybe people are working on it already. But that would be great if that only exists. Whoever it is, nobody is to own that, right? It's like oxygen and the sun, and that's, they are representations of the world that should really be available to everybody.
Let's come back to a little bit more reality, Peter, not looking so much in the future. I want to ask Jan at the end, is there a business model for these AI process models? You have the component, you have a digital twin of this component, and now you can also sell an AI model to your customer. Is it an idea of Festo?
Yeah, there are different business models behind it. One, you could sell services for the component or for the digital component. You could make it as easy as possible for the customer. Well, if you want to have money for it or not, I would say no, because it's just a benefit. If you buy with us, it's easier for you. But there are different approaches what you could sell in the end in a business case. But I think the most promising at the moment is in engineering tools, because we don't have this whole chain yet. We cannot build a whole machine or a whole component from scratch by AI unless it doesn't have movable parts and you very much make it simpler. But in this engineering process and how you find your solution and also how you make it run, right? So you get your system that you ordered, and then it should, in the best case, already be programmed for you, or you don't have to do anything, or just very simple steps, because that would enable automation for a lot more people, not just for experts and not just within, let's say, the manufacturing industry or the bigger industry, but you could think of service robots, agriculture, you could think life tech, you could bring automation to a lot more fields and help a lot more people to do what they're actually good at, to interact with other humans or be creative and not use their time setting up a system that is poorly designed.
Peter, last question to our guest.
Oh, no, just thinking further on what you just said, Jan, and also providing capabilities in our part of the world, at least, where we're here in Germany, I'm sure other parts of Europe, other parts of the developed world, we are lacking manpower everywhere. And this is becoming a real issue. My feeling is that until 5 years ago, when we talked about automation, it always had a negative social aspect. You always had to explain, yes, we're putting in a machine, we're putting in maybe a robot. Oh, yes, but everybody's going to keep their work, or maybe not. I mean, that was always a big thing. And that has been changing in the last, I would say, half a year maybe. It's that people are looking towards, because we're not going to have the humans to do all the things that we want to do. And I think there's a huge potential. I want to say thank you to you, Jan. It's very interesting. We talk about, being at your stand Hannover Fair 3 or 4 years ago, and in that time frame, which at that time almost sounded not like a joke, but like, Jan said, oh yeah, in the future, algorithm's going to do this. And we looked at him and said, like, oh. And today, here we are, and you're actually developing exactly these systems. Very interesting.
It was a pleasure, Jan. Thank you very much.
Thank you for inviting me. The pleasure was all mine.
1, 2, 3.
We wish you a Merry Christmas. We wish you a Merry Christmas. We wish you a Merry Christmas and a Happy New Year. Perfect.